Hi everyone. So we're going to look at circumference of circles today, and it's quite a nice one because it's an experiment, which is my favourite way to do maths, is to figure things out rather than just be told them. So by now you should have done this. You should have done this activity here. I've done most of mine. I've just got the last circle to do, so I'm going to do that with you right now. So what I'm looking for, and this is circle E, this little one here, I have labelled them quite badly actually. It took me a couple of goes to get the right circles. Is I'm going to, first of all, measure the diameter. Remember, that's the line that goes all the way across the centre, and that's 2 centimetres long, that diameter. So on my chart here, under diameter, 2 centimetres. Radius, please remember the connection between radius and diameter. The radius is the line, like in circle A, from the centre to the outside. Okay, so it's half of the diameter. So if we know the diameter is 2 centimetres, and the radius must be 1 centimetre because it's half of that. And now the trickier part, the circumference. So I've used a piece of string. Use whatever you can get your hands on. A bit of ribbon or something will do the job. Can't use a ruler because we can't bend it. Unless you've got one of those bendy rulers, actually. I've seen some people with those. It might work. And I'm just going to lay this all the way around the edge of the circle. Okay, so there we go. So about to there. Now obviously this isn't going to be the most accurate measurement, but it should give us an idea of what's happening. So if I measure that, that is 6.5 centimetres. I think you can probably just about see. 6.5 centimetres that goes up to. So the circumference, so 6.5 centimetres. And then I've given a bit of a calculation here to do at the end, using the figures on yours. So I've asked you to do circumference divided by diameter. So on your calculators, we're going to have on this one here, you might have got a slightly different number here. That's fine, because not everyone's is going to be exactly the same, because it's a piece of string. Okay, and we're getting 3.25 for that calculation. And like I say, your circumferences might be slightly different to mine, because this isn't the most accurate thing we can do, is it? But looking down here, you can probably see a bit of a pattern actually. These have worked out quite nicely, that I've got 3.25 3 times. Now 3.25 3 times, we've got a 3.2 and a 3.3 recurring. That means that 3 goes on forever, 3.33333, forever and ever. So there is a number quite close to that. And remember, we won't have seen it right now. You might have done, you might have got the actual number or very close to it, which is, I would be hoping to get quite close to 3.14 for this experiment. But like I say, accuracy isn't ideal with the way that we've measured. Okay, if we had a more accurate way of measuring, we'd have got much closer to this. So what we can say is that most of these numbers, they're kind of near to 3.14. And, oh, I'm writing that off the bottom and you can't actually see it. There we are, to 3.14. And we should know, or I hope we'll know by now, that 3.14 is what we shorten the number pi to. Okay, so that's the Greek letter pi. It's just a Greek letter. We use it to represent an infinite number. So pi is a number that goes on forever and ever. It doesn't end, which is why we use it a lot when it comes to circles, because circles don't end. Okay, and if you zoomed in on a circle and in and in and in, kept on zooming in, it would still be slightly curved. You're never going to find a flat part of it. So that's why the number we use with them goes on. So we're looking here at circumferences, and what I want to know is, using the diameter, is there a way we could have calculated these numbers? Is there a way that we could have done it? And the answer is that yes, there is a way, because all of these here are getting quite close to 3.14, and that is what they are representing. They should all be pi, and had we been really accurate, which isn't really possible with a piece of string, we should have had each one of those at pi. Okay, but you can see we're getting some pattern. They're all quite close to each other. So to find the circumference, if we found this number here by doing circumference divided by diameter, let's write that down. Let me get a piece of paper to write that on. So we did circumference, I'm going to call that C, remember that's the distance around the edge, divided by diameter, D, equals pi. Or we can rearrange that, can't we? What is the inverse of dividing by d, dividing by diameter? The inverse is to multiply by the diameter, which gives us, just C on this side, because they'll get rid of each other, equals pi times diameter. I'm just going to put the d there. We don't have to put the times sign in. Remember, when we've got variables next to each other, we have to put that, but don't have to put in the multiplication symbol. So that little experiment, and I'm hoping it has just made it easy to remember this, because like I've said before, I'm not a big fan of trying to remember everything in maths. If we can remember how we got there, it means we don't have to remember all these fiddly little formulae. So think back to this experiment whenever you see circumference and think what you did and how it got you to this formula. Okay, what happened? So now we can put that to some use, and I've got 3 questions here for us to try. Okay, I'm just going to kind of copy that up onto here. So we've got circumference equals pi multiplied by diameter. Okay, so we're just going to have that up on the top. Right then, so the first one here, now interestingly enough, we don't have the diameter here, do we? We've got the radius, which is going to make it tricky because the formula asks us to use the diameter. But think back, we did it just at the start of this activity actually. Remember, to find the diameter, that's if we came all the way across here, it's going to be double, okay, double the radius. So the diameter is going to be 6 centimetres. So that shows us that for this circle here, we've got circumference equals pi times 6. And on your calculators, we should have 6 pi. I'm going to shift and pi to get the pi button at the bottom there. Shift and pi. And it gives us 18.84955592. And then remember to always write down your full calculator display in an exam, but then round it to whatever it is that you ask you to round it to, usually 1 decimal place, and just, don't forget your units, 1 decimal place, and it is in centimetres. Okay, it's not centimetres squared, it's still a length, it's not an area. Okay then, so for this one here we can do the same thing. If the radius is 7 centimetres, that means that the diameter must be double that, it's 14 centimetres. And so circumference equals 14 multiplied by pi. Okay, I've just written them the other way around, which gives us, back to my calculator, 14 multiplied by pi, which gives us 43.98229,715. I'm going to round that to, oh goodness me, well if we round it to 1 centimetre, sorry, 1 decimal place, it's actually going to round the whole thing up to 44. Okay, so I'm going to put 44.0 centimetres, because if you're asked to round to one decimal place, you have to give it, even if it's a 0. 1 decimal place. Okay, and now this last one, which is bizarrely the easiest of the 3, because we've already given the diameter. But don't trip up, because sometimes when you've done loads like this, you automatically look at this number and just double it. Okay, just be careful that you're not just diving in and doing what you've done on the last questions, because it's not necessarily going to be the right thing. We've already got the diameter here, so we don't need to double this number. So we should have circumference equals 16 times pi. And these will only come up in a calculator paper. Oh, I've turned it off. 16 times pi, which is 50.26548246 when we got space, and again to 1 decimal place, that's going to be 50.3 centimetres to 1 decimal place. Right, so there's 3 examples. Copy those down if you need to have that into your books. That would be useful, at least to have 2 of them down, 1 of each, so 1 with the radius, 1 with the diameter. And you can go ahead now and have a go at the sheet I've given you. There are some interesting questions on there actually. I'm going to let you have a go at it, and in a couple of days I might put up another video with some more problem solving questions which involve this. But first of all, I'd like you to get a real good go at just practicing the basics first.